Hi class, this is Mrs. Norris, and we have finished Chapter 3, Section 1 and Section 2, which has basically been solving what we've called systems of equations. Now we're going to step back into 3.1 and 3.2 and just talk about the word problems involved there. This is a very important skill, so we're going to spend a whole class day on it, including this video. So let's start just by talking about what we mean. We're going to have what we call various templates for the different kind of word problems, and they're going to look something like this. We're going to have something times x plus something times y equals sum total, or we're going to have an actual equation that represents y equals mx plus b. The m is usually the slope, remember. That's your per item that's listed in the equation, and the b is some starting point. So let's jump right in here. Let's talk about, we're going to call this example 1A. This is involving tickets to a fair. So the first thing we're going to do is recognize that we have two different types of tickets. We have a children's ticket that costs $1.50 and an adult ticket that costs $4. We're also going to read the next sentence, which says, on a certain day, we had 2,200 people enter the fair, and we made $5,050. So this first template that I want you to write down is a template that looks like this. It's first going to have an equation that involves how much total money they took in. And it's always going to have some per x plus some per y equals the total money that they took in. And the next equation is going to involve the number of items that they had. So we're going to say for x number of adult tickets and y number of children tickets, and we're going to say how many total tickets they sold. So the first equation we're going to write is the money equation. Since the adult ticket is $4, I'm going to go ahead and call this 4A. You can always use x and y if you want to. I always change my variables to match the problem, because when I'm finished then I know what it is that I've defined or found the answer to. So this is for adults, $4 per adult plus $1.50 per child equals $5,050. Okay, so this is all the money stuff. The next equation that we're going to come up with, remember a system of equations is two equations. So all of these word problems are going to have two equations. The second one is just the number of items. So for however many adult tickets we sell, A, plus however many children tickets we sell, C, we should have sold 2,200 tickets based off the fact that 2,200 people entered the fair. Okay, this should look familiar to you as something we've been doing the last couple of days. Let's use substitution by first rearranging the second equation, solving for A. Remember, when I substitute, I always put my value in parentheses. I'm going to take this representation of A and plug it into this first equation. So it's going to be 4, which was times A. We're going to substitute in the 2,200 minus C for A. Simplifying this, it now only has one variable. We're going to distribute the 4. We get 8,800 minus 4C. Then we're going to combine like terms and subtract 8,800 from both sides. We're going to get negative 2.5C equals negative 3,750. Dividing 3,750 by 2.5, we get 1,500 child tickets. Okay, and that's going to be our answer to children's tickets. Now, they also want to know how many adults attended, or how many adult tickets we sold. So we have to go back up to this equation, which is the same as this equation, and plug in the 1,500. So we take A equals 2,200 minus the child's tickets, plug in the 1,500, and we get that we sold 700 adult tickets. Okay, this same template is going to be used for a different type of problem, so I'm calling this example 1B. This one involves coins. When you have coins, you're always going to have a money equation and then an item number equation. The money equation is something per whatever the coin cost is. Here, in our case, we're going to have pennies, so I'm going to put a 0.01 there. And we're going to have a per cost for the second type of coin. In our case, it's nickel, so I'm going to put 0.05 there. The total amount of money or total cost here is going to go here, and the number of items is going to go in the second equation. So the first one is easy. We're going to write a penny value times the number of pennies plus a nickel value times the number of nickels equals the total money we have, or $8.80. The second equation looks a little different than this. Sometimes in a word problem they will say you had a total of 10 coins or something like that. If that were the case, then you'd write n plus p equals 10. But in this problem, they actually said there are twice as many nickels as pennies. So when we're talking about number of items equation, I'm going to write it like this. There are twice as many nickels as pennies, so the number of nickels is equal to 2 times the number of pennies. This makes it easy for us to substitute because we already have n by itself. We can take the first equation and replace n, wherever you see the n, with the 2p. Multiplying 0.05 times 2 gives us 0.1. So we copy this one. This on your calculator gives you 0.1, and we copy this one. Combining like terms gives me 0.11p. 0.11p equals $8.80. Dividing by 0.11, we get 80 pennies. I can plug the pennies back into the nickel equation and get 160 nickels. Okay, the next type of problem, and the next example type, is involving money again, but this time we have two different situations involving the exact same thing, but two different situations. We're going to call this template 2. Template 2 is simply writing a y equals mx plus b formula for both situations. We're going to write one for Jenna. Jenna's equation looks like this. Y equals, she started with 1500, that's my b. I know I moved it to the front, but that's because that's what she started with. That's my y-intercept, if you will, my starting point. Plus, she adds $30 into her account each month, so we take 30 times x. In this case, x is going to be the number of months. We could write a similar equation for Lewis. Lewis started with 2400, but he's a bad spender. He takes money out of his account each month. He subtracts $30 or takes out $30 per month. So his equation looks like this. The question asks us, in how many months will they have the same balance? Okay, they want when y will be the same. Since we set both of these equal to y, we can now set them equal to each other. So we set Jenna's equal to Lewis's. This is a simple algebra problem, right? We're going to add 30x to both sides and subtract 1500 to both sides. We're going to get 60x equals 900. Dividing both sides by 60, we get x equals 15. This is telling us for the number of months that it would take for Jenna and Lewis to have the same amount of money. So after 15 months of Jenna doing something good and putting $30 in, and Lewis taking $30 out, their amount's going to be the same. The next part of the equation is asking us just what will be their balance. How much will they have? So I went ahead and plugged the 15 months into Jenna's equation and also into Lewis's, but I could have just plugged it into Jenna's because when you plug it into both, you get the exact same thing, or $1,950. Okay, another similar equation. Remember, our template is y equals mx plus b, a per and a starting point. This one is about water in a tub. We start with 16 gallons in the first equation, and we subtract 1 gallon per hour. Okay, x is the number of hours. We drain, so we subtract. The next item is a basin. It starts with 3.5 gallons, and it loses a gallon every 6 hours. So we're going to make that a 1/6. This is the system of equations representing this situation. We just aren't adding the slope or the rate. We're subtracting it because it's draining. The next part of the question asks us if they're both draining at the same time or begin at the same time, how soon will the tub have the same amount of water? So we do the same thing. We set those two equations equal to each other. Now when I go to solve this, Instead of changing this on my calculator to a decimal, you're more than welcome to do that. I like to go through and multiply all 4 of my terms by 6. Doing that gets rid of my 6 in the denominator and changes all these numbers. So 16 times 6, negative 1 times 6, 3.5 times 6, and this one times 6, which makes it negative 1. Looks like this: 96, negative 6x, 21, negative 1x. Now it's a straight line algebra problem. I add 6x to both sides, subtract 21 from both sides, divide by 5, and I get in 15 hours they'll have the same amount of water. Again, they want to know how much water they're going to have during that time. So I'm going to plug the 15 into one of the equations. I picked the first one. It's easy for me to subtract 16 minus 15. They're going to have 1 gallon left after those 15 hours. Okay, the last type of problem is similar to what's explained in the book. So this is problem 14 from your textbook from section 2. It's basically the same type of template from number 1. It has a percentage kind of a thing, or a per, for 2 different types of things. And then it has a total. This time it's going to look a little bit different. The total percentage or total amount of money kind of a thing, since we have an 85% gasoline and a 25% gasoline, we're going to make one X and one Y. But what she wants her total to be, I'm not going to re-record that, sorry about the bell, is she wants her total to be 50% of the 20 gallons that her tank will hold. So the equation looks like this, the first equation. The second equation should be pretty easy for you to come up with. This one I know is a little bit hard. We're going to have X plus Y equals 20, because that's the total number of gallons that her tank will hold. So X represents the number of 85% gasoline gallons. Y represents how many gallons of the 25% we need in order to have 20 gallons of the 50%, which is all represented here in this problem. Rearranging the Y by subtracting X from both sides, we get something to substitute. We're going to substitute this where we see the Y, and we're going to solve for X by distributing, combining like terms, etc. We get, let me move that down just a little bit, we get X equals 8 1/3 gallons of 85%. Okay, now we need to find how much of the 25% we're going to have. So we're going to use this equation. 20 minus 8 1/3 is 11 2/3 gallons of the 25%. All right, I'm over my usual time limit, so I will see you tomorrow. We will practice many of these word problems in class. Have a great night.